Okay, so we've already looked at frames, and by being introduced to frames, we learned about two force members. And then the other thing we've also looked at is we looked at trusses, which have zero force members. So you've been introduced to the term of two force members, and you've also been introduced to the term of zero force members. So we're going to do two trusses now, and two truss problems, and there are two different ways that we could analyze trusses. The first way is method of joints, and the other one is method of sections. And we're going to specifically look at both of them. But to begin with, let's take a look at this truss problem. So, would you say that these are all two force members? So how many members are here total? There's one going from A to B. Is it a two force member? It's a two force member because there are no loads happening in between those 2 points. All the connections and the forces are happening at the end, so it's a two force member. How about BC? Same kind of thing, nothing happening in between, but there's a load at B, there's a pin at B, and there's also, what's at C? That's a roller, right? So everything is going on at the two ends, two force member. How about from A to D? Same thing, this is a two force member. From D to C, it's a two force member, and B to D, it's a two force member. So we're looking at a truss that has 1, 2, 3, 4, 5 two force members here. So in whatever method of analysis we do for trusses, the first thing we do is we take the whole structure away from its main supports. So I'm going to do that here. So I have A, I have B, I have C, I have D. I know that the dimensions are 8 feet, 4.5 feet, 6 feet, and they're also telling me that this is at an angle of 3 to 4. Sorry, 3 to 4. And we see that the external forces here are 1,200 pounds, and there's a 1,600 pound force here. And the question for this problem is to find the forces in each member. And how many members did we say that there are? 1, 2, 3, 4, 5. There are 5 members total. And we learned that there were also considered two force members. If there are two force members, that means that the force that's going on in each member is axially loaded. It's either a tension or a compression. So first thing we do is we take the whole structure away from its main supports. And we saw that point A, there's a pin. So I'm going to put an AX here and an AY, because those are the reactions at a pin. And at C we saw it's a roller, so I'll just call it N for normal, or you could call it CY. So the first step, take the structure away from the supports, its main supports, and determine the reactions at the supports. So our goal right now is to find the reactions at support A and B. So how many unknowns do we have? We have 3 unknowns. How many equations do I need? 3 equations. How many bodies? 1 body. What body do you want to analyze? The whole structure. And we drew the free body diagram. So far, what do we have missing from our free body diagram? We have to have the X and Y axis. So what equation do we want to do first? How about some of the forces in the X? Is that a good equation? I think so, because I'm going to find out. It's one equation with one unknown in it. AX plus 1,200 equals 0, and AX turns out to be negative 1,200 pounds. How about some of the forces in the Y? Is that a good equation? No, because it has two unknowns in it. So let's do another equation. Let's do sum of the moments about A. So we have n times 12.5 positive. We have 1600 times 4.5 negative. And we have 1200 times 6 negative equal to 0. And n turns out to be, let me take a look. 1152. 1152 pounds. So just as a reminder, let's say I got a negative n here. What would that mean? Well, one, your first answer might be, well, if I got a negative answer here, it really means that n is going down. But is that possible? No. The normal is always a compressive force. It's always going towards the body. So if you got a negative for n, what would that tell you? You made a mistake somewhere in the math. Okay, and then the last equation, sum of the forces in the y, which is ay plus n minus 1600 equals 0. And ay turns out to be 448. Okay, this is nothing different than what we've done before. We have a structure. We found all the main supports. So if we want to redraw this now, I'm going to go back to our original diagram, and I'm going to erase the supports here because we removed it from the supports. And I'm going to put a normal now of 1152 pounds. And I have an AY of 448, is that right? 448 pounds. And I have an AX, I'm going to leave it drawn in the same direction I have it. So I have an AX that's equal to a negative 1200. So I'm not changing the direction, I'm keeping the direction the same. Okay, you can put it on pause.